Boa tarde a todos. Bem-vindo a mais um CICS Talks. Essa é a 12ª edição do nosso CICS Talks. Meu nome é Vanderlei Jones, sou coordenador do Centro de Inovação em Construção Sustentável, né? O Centro de Inovação em Construção Sustentável, ele é uma iniciativa da Escola Politécnica, né? Que tem por objetivo acelerar a inovação na área de edificações. Nós trabalhamos com uma visão que nós precisamos reunir a sociedade, a academia e as empresas, né, para gerar resultados melhores, né. Nós trabalhamos pensando em meio ambiente, em produtividade, digitalização e em questões sociais, os nossos grandes desafios, a gente precisa enfrentar eles, né. Mas, fundamentalmente, nós tentamos ter novas ideias, né, para cada um desses problemas, ou ideias que atacam vários desses problemas. E hoje, nessa talk, isso não é uma exceção, né. Essa atividade, o CICS Talk, faz parte do nosso esforço de formação, difusão e demonstração, né. Então, aqui estamos fazendo difusão, nós vamos começar em breve, vamos lançar um curso sobre avaliação ambiental, desempenho ambiental, voltado para edificações, né? Temos também atividade de informação, né? A nossa visão é uma visão de competitividade, né? Nós achamos que as novas soluções, elas têm que ser também economicamente competitivas, né? Então, esse é o CICS é um ecossistema de inovação, a gente reúne muita gente, né? A gente quer que essa marca seja percebida pela sociedade como a marca da inovação na área de construção. Então, nós estamos fazendo o edifício CICS, onde nós fazemos demonstração de tecnologia, a gente tem seminários, a gente tem fórum, a gente tem atividades de educação, né? Construção digital, que é a nossa agenda de hoje, coworking, né? Vamos ter um coworking, a gente vai ter projetos de pesquisa e inovação. Em breve nós teremos mais uma cátedra, nós já temos uma cátedra construindo amanhã, né? Nós estamos aqui fazendo os CICS Talks, né? Essa aqui é uma visão do edifício do CICS, que a gente está construindo aí com doação de empresas, e cada pedaço dele é uma tecnologia nova que está sendo demonstrada, né? Projeto do Roberta Flau e da Milene. A gente, então, está atuando em vários setores, graças ao apoio de parceiros, né? Os nossos principais parceiros, Intercement e ArcelorMittal, mas nós temos muitos outros, todos eles muito importantes, todos eles trazem novas ideias e novas tecnologias para que a gente teste no CICS e elabore e faça pesquisa, né? Eu queria agradecer a todos os nossos parceiros, né? Bom, hoje nós temos no CICS Talks um tema que reúne a parte ambiental, reúne com a parte de digitalização, reúne a parte de industrialização, de produtividade, né? Nós temos um convidado, o professor Mohamed Al-Hussein, né, que vai falar sobre construção modular. Ele é da Universidade de Alberta, no Canadá, né, e ele é uma das pessoas mais ativas nessa área de construção modular e de novas técnicas de construção na América do Norte, né? Ele dirige lá de dentro da Universidade de Alberta, ele é o chair tem uma cadeira que chama Industrial Research Chair, uma cadeira de pesquisa industrial, uma coisa parecida com a Embrapi do Brasil, que tem poucas no Canadá, né? Então ele faz pesquisa junto com a indústria, que é uma coisa que nos agrada bastante bem, muito, né? Mas ele fundamentalmente está centrado em pesquisas na área de industrialização e da construção de edifícios, né? Ele é uma pessoa, além de ter esse trabalho junto com empresas, ele é um acadêmico com uma carreira muito sólida, com mais de 190 artigos publicados em periódicos científicos, em conferências, né? Já andou o mundo, né? Ele vai falar em inglês, né? No sistema aí de vocês, eu acho que é possível vocês habilitarem as legendas, né? Funciona bastante bem as legendas em inglês, vocês vão poder ler o que ele está falando, né? A gente queria Também mencionar para vocês que as perguntas vão ser feitas depois do evento, mas vocês podem ir usando o Question and Answer ali para já ir listando as perguntas, permite a gente se organizar e editar um pouco a ordem das perguntas, fica um pouco mais interessante, né? Finalmente, tenho que agradecer aqueles que nos apoiam, né? Eu já falei dos patrocinadores do CICS, mas nesta edição do CICS Talks a gente tem o apoio sempre da Poli, o CICS está sediado na Poli, no Departamento de Engenharia de Construção Civil, né? Da Cátedra Construindo Amanhã, que a USP mantém junto com a ArcelorMittal, a Lafayette Construção, que é a parceira do CICS também, e a CMC Módulos, né? Estamos registrando também o apoio do Modular Building Institute, que é um instituto norte-americano, da qual o professor Mohamed Al-Hussein faz parte, e a Lafayette também é sócia, né? CBCS, a ITE, e particularmente eu queria agradecer ao professor Al-Hussein e à Universidade de Alberta por terem dado este apoio. Então, as perguntas vocês podem fazer em português ou em inglês, a gente ajusta, né? E de novo, né, no final. Ok? Professor Al-Hussein, thank you very much for accepting our invitation. I will pass the floor to you, and I wish we can keep in touch and perhaps generate new ideas together, and I will be delighted if we could build something together, because we share quite a lot the view of a better future for the construction. Thank you very much for accepting our invitation. The floor is yours.
Well, Professor Johns, thank you very much for this opportunity. It is really a great pleasure for me to be part of this organization and part of these seminars. You probably see in my background, I'm really proud to tell you this is a picture from a company that's in Brazil, which is Lafayette, and I will probably share some of the experience we have with Lafayette in the past. So without further ado, my presentation will be visual. I'll try my best to make it as pictorial and visual as possible with less talk. So I'll put it on the animation mode to see if it will flip to that. And as was introduced, and thanks for the introduction, I'll go through some case studies with you today, and then highlight a little bit of lesson learned as we go in modular construction. So these are pictures which I feel good about Australia. Really, they lead the world when it comes to high-rise buildings. So they managed to prefabricate high-rise buildings. They managed to prefabricate, include beauties and architecture complexity to build buildings modularized offsite and bring it to the site. And there is lots of examples Australia has that they feel good to share and to discuss. So the architecture challenge has been really solved with the abilities of building the product in factory and shipping it to the site. So there is lots of examples. I'll stop here when it comes to Australia. I'll go through a case study which is again worth celebrating. Mecklenburg College at the university in Pennsylvania wanted to replace these 7 bungalows with 5 new buildings, and the question was, could this be done in one particular summer, in one summer alone? So I'll show you this clip.
Students at Mecklenburg College will have a new place to call home. Construction crews are almost done putting together 5 new dorms in just 10 days. Sam and Paul Smith of the WFMD's Johnson Moses line at Mecklenburg tell us why it's not Jocelyn. When it's pretty actually construction crew together these buildings, it's like putting together a puzzle. It's hard to say which should be done quicker. The pieces are falling into place at Mecklenburg College. Construction crews are almost done putting together 5 new dorms in about 10 days. I think it's never so many time ago. Where did these buildings come from? The buildings are actually built in factory and then delivered to campus. A giant crane sets each piece in place. This type of construction called modular or off-site construction.
So these are the 5 buildings which fabricated modules arrived on site, and the general contractor, in collaboration with the modular manufacturers, they were able to give out a full building of this size every 2 days. So the final look of these buildings really something to celebrate. So modular industry can say, yes, they can build matching the current practice or on-site construction versus off-site construction. The brick you see in this facade was done in the factory. The covering between the modules was done on-site. So it's hard to tell which one is factory-based and what is not. This part was also built on-site. There are some challenges to some associations associated with modular construction is the schedule. Usually we schedule on a daily basis, a day by day, but when it comes to modules that arrive fully fitted and arrive on a very high rate, you need to schedule in a minute per minute basis. So basically you are doing simple tasks very quickly. So the schedule move from days to minutes. And again, you need to make sure that trades are assigned locations and time, what need to be done and when. So that one of the challenges. The other challenges we have, some of the modular manufacturer, they move the work from site base into the factory, but they use the same tools, the same techniques, which is really conventional under construction. But there is ways to improve efficiency, improve the demand on the physical abilities of the people. So I'm showing you some of the examples which you can see some of these factories to build a full length of a side, which is really what they call it rim board that carries the house. This is wood framing. You can see the human has to move around and use simple machines. But if one look at the lean construction principles, all are violated, whether it's motion, weighting, transportations, defects, and so on. So you can see this could be looked at and changed in a better, the way it could be built better way. If you can see the humans, they have to move back and forth, and then they have to put all these pieces together, and then one individual will move or two will move back and forth. There's a lots of movement, a lots of motions, a lots of transportation. Because this has been done, and it's been done for a long time, and then somebody will move in and bring in the tools that needed to fasten these joists against the rim board. You can see this person will carry the nailing mechanism or nailing gun, we call it, and you have to apply 5 nails or number of nails in each one of these joists. So there is lots of work, lots of physical really work involved in this particular operation. This could change by simply really modifying this work to putting the machine you need where you need it, and then let the individual just change the location of that system into where you need it. And this way you can probably increase efficiency, reduce the transportation, you reduce some of these principles of lean, which is being violated in the current practice as all the time. Some other techniques, maybe you can use the gravity to your advantage, bring the material next to you where you need it, and then try to apply some of that into the process of making that flow. So very simple operations. There is no mechanization, no automation, just simple machines that can help move faster or better way of building the way you build. The other challenge we discover also, some work could be done on the production line, which should be taken away. So you can this is the opening for electrical sub-assemblies for doors, windows, and also locations and measuring and so on. So there is a lot of work in the factories. We can see in the top part here showing how the current practice versus what's supposed to be. And we need to promote to a degree, a little bit higher degree of automation rather than just using the conventional construction. Let the work be in front of you rather than climbing up and down. Have the things pre-built, pre-developed, prepared in advance, rather than being put on the factory in the production line. My philosophy is fix the people, fix the tool, let the product move, rather than having the people and the tools to be fetched and brought in to the location where you need to build. The other challenges I discover also, we tend to build the way we build on site. So the house is made of many walls. We'll build each wall alone. The factory could lend itself to new opportunities that join these walls together. We call it multi-wall. And when you look at the house, instead of 30 to 40, maybe more than 40 walls, that a closet, a washroom, or other place wall, you can really build the entire house between 6 to 14 walls maximum. So this way you can really gain efficiency, and you may reduce. To do that operation. The question, what are we going to do with these hammers? Because we love hammers in construction, so I propose to use them for door handles, which is being used in some of the restaurants. Another challenge I discovered on the industry, whether offsite or modular or in construction, the use of tapes. People love measuring, lots of measurements, and it really takes away lots of time of the people. So also the other dimension, which is volumetric prefab manufacturing. So if most of the manufacturers jump quickly to volumetrics, doing it in 3D concept, and then people will start moving between the stations and back and forth and so on and so forth. So this is, yes, you may have an element of lean principles. But again, I support more segregating that into a single dimension rather than a 3D dimension. I'll share with you some of that in the next couple of slides. So this is an example of how if you apply the automation, use the right product, you can really, with certainty, with predictability, you'll say, I can frame, and the framing will take 1% of the labor that is needed to build the house. So what you can look at, this human is moving with little amount of movement where he's standing, and the machine does the work. So the human is fixed, the tools are fixed, and the product moves. Other places you might find way higher automation. So if you look at the interaction between human and machine, the previous slide shows probably 50-50. Here you can say the human is about 10% involved to 15%. The rest is done by the machine. Again, predictability. That add additional 1% to the labor, because I know for sure this machine will work and operate without having a need to be associated or be used by a human. And you move on to others. So if you look at this here, there are multi-walls here. So there are probably about 5 or 6 walls built together. And they guaranteed that you can build this wall within 8 to 12 minutes because it's a multi-wall, regardless of the number of walls, the windows and doors in that particular wall. As I said, I promote a single dimension instead of having volumetric, ideally to work on a 1D or a 2D environment here. So you can really have people working from both sides and at the height of the human. And you can guarantee predictability again. So I can, with the budget we have for windows to be installed in this factory, which I'm showing you here, is 6 minutes, regardless of the size of the window, because there is an aiding devices that will help the workers to lift the window, put it in place, and then they have 6 minutes in total to tide it up and to make it ready to have it ready for the house, and so on. And you move on to the rest. So this particular builder, it's a panelized builder. All panels are fabricated. They can build 4 to 5 or 6 homes per shift or per day. They can build the home in 6 hours, a small one. Larger homes, they can build them in about 2 days. So they call themselves 6 hours builders, and because they can provide predictability and accuracy of how they build and what they build and how they do the operation. So moving fast with this animation. So the second floor is in place, and then the sections of the roof and the components that add up to this house will be added as you go. So this house was built in 2 days. For this particular size of the house. Now myself here, I start to put machines. So make these machines, and those machines were built and designed in my lab. At the moment we use students primarily, supervised by graduate students, masters and PhDs, but undergrad from co-op, from mechanical, electrical. So this system, what you see here, was completely designed, and it is built in my lab, tested as a full-scale testing. So it is really ready for potential commercialization in the future. That's what I'm working on. So as you can see here, the human, all he has to do is apply the components, and the rest is done by the machine, which will take it. The tape is no longer needed. Nobody measures anything, and the work is being done according to the sequence that is applied or required to build the wall. So this is to the wood framing. You can see here components will be added, additional tools. There are 3 tools here, which is nailing, drilling, and cutting, which is the circular saw that is used in this particular operation. Working closely with Lafayette in Brazil on the light gauge steel. So this is a system which we propose. Again, we have a new generations of that. Lafayette requested a little bit of changes on the system. So the first generation was built what you see here in terms of building the wall, and then you get nails or screws will come and apply screwing on top of each one of these studs, what we call them. So this is light gauge steel, which is Lafayette is really leader in the world in terms of applying light gauge steel. So this will probably make add efficiency to the process and perhaps predictability. So Lafayette wanted to know how long does it take to build a wall with predictability today and tomorrow or a year from now. So the machine was tested and built, and we're still testing. So this is the samples in my lab. What you can see here, what is being tested for this particular machine. So the screws will apply. We try to use different thicknesses to make sure that the speed is controlled in a way that will work consistently. So screws from the top, screws from the bottom, and really the operation will be much faster than what could be done manually. We tested a couple of panels, manual versus machine. The manual, 6 people, they did it in 7 minutes. 2 students, they put it in 4, and the machine did the rest in 2. So there is a lot of gain in terms of efficiency when it comes to using automations and mechanization. There are new generations of this, which will make it even more efficient and faster we move forward. The last product I want to touch base is the Precast, which is probably it's a premier product that is used in lots of many countries around the world. So Precast in China is really the largest amount of Precast in the world. You can find it in China. Austria, I look at some examples, they do Precast, and Finland, they really advanced, in New Zealand. So there's a lot of advancement in different places. I came up with a system here to reduce the amount of concrete from using a sandwich panel into what we call a rib structure. So this rib will be all concrete, and the load is carried by those segments, which is in front of the. We're working with USP, with Professor Johns as well, to see if we can incorporate Precast with light gauge steel. So we marry the 2 systems. Light gauge steel have the abilities to carry load, but again provide a lighter member when it comes to carrying these components from one place to other. So I have done some of those in the past. What we still have to look at, Professor Johns in University of São Paulo will do a little bit of test because they have more experience than us in terms of structure analysis, thermal, and so on. So there's a lots of challenges. We will be working together with Professor Johns and Lafayette to see if we can overcome some of these challenges. What you can do also, you can have a platform give you the textures that make it look like a brick. We added a little bit of bricks, a full brick or half a brick when you lift the panel. So if you look at this panel, it's really a composite of 3 members. We got light gauge steel, we got the concrete, and we got also the brick. The brick here is really primarily used as a facade and architecture look. It may add some value to the insulation, but the criteria here to use it for a different look and facade for the product, the final product. We believe that Precast could be probably used in many applications in residential construction, So a couple of projects we tested here. We built lots of underground basements in Edmonton. We tested connections, and there's still lots to do, but it's a very mature industry, the precast in the world in a different capacity. I'm showing you photos here from a company in Spain which uses a similar structure which I was talking about, the ribs that carry the load. But they make it in a way that fit on a trailer, on a truck, I mean, and they ship it all around Europe. So there's quite a few examples they have. The company called Compact Habit. I think it's worth for those audience to visit that factory. They've done really remarkable things when it comes to precast. So as you can see, their modules, volumetric, are that can fit in the size of a truck, that can be shipped anywhere in Europe. They patented an interesting technology to, when precast comes, the challenge we have always is the connections and how to deal with the joints between panels to panel, panel to floor, panel to wall, to ceiling. So they came up with a system. They pour the concrete in the walls, and then they lift it when it's mature after 4 or 5 hours of curing. They will put the flooring, which has become a monolithic structure in terms of concrete. So that eliminates the fear of the effect of joints, so it will become really more monolithic rather than. So they have a patent on this particular technology, and if that's of interest to those who are listening to this presentation, I would urge you to contact Compact Habit. You may have some discussion with them around this particular application. Finland has really a long history of precast. They started probably 70 years or more than that, adding brick on the precast, and they build what you see here on the my left-hand side is all built in a factory. Today they add more modern style to the technology, and they still build really. So it's a good model to see if those interested in the precast. This particular panel arrived from the factory with the colors you see, 3 colors in one single panel. And you can see they said they can build a building with 0 concrete on site. They have a very good technology on how to make the flooring system and how to. So this building, I was told, that was entirely built in a very short period of time, all precast, ready from the factory in terms of colors and painting with 0 concrete on site. China is a leader around the world in terms of precast. They build way more precast than any other country in the world. The only challenge I have seen that the code require to put fresh concrete when you have when you're connecting floor to wall or wall to wall. That, in my opinion, defeats the purpose. But again, it is code rather than anything else, really. So a precaster, they have to leave the rebar outside so they can connect 2 panels, and they can, in this case, a fresh concrete could be added to the system. So the last part of my presentation, what opportunities COVID-19 brought in and how the manufacturer can really accommodate the need for that. And that basically more research at the moment than practice, but again, some of it will start to find its way in the practical applications. There are 4 areas I'm being interested in. One is digitization. I know Professor Johns is preparing for you, those who are interested in carrying with these seminars that University of São Paulo is organizing. They will have a full session on digitization, to my understanding. The other part is really robotics and automation. And the third part, I said, linear manufacturing. So instead of jumping into volumetric, if you can really separate that into linear, either 2D or even 1D. And the last, which is the virtual reality and machine learning. So I'll touch base on those and quickly before I conclude my presentation. So digitization allows for people to see information, instructions digitally rather than the foreman will walk around. That will reduce the interaction between human, and perhaps when we have a situation such as COVID-19, will help the manufacturer continue working and reduce the effect of the work we do, the way we interact as human, instructions received and so on could be all. And you may imagine the people could probably become a transmitter to a disease or to viruses if you use paperwork. The other part, which is robotics. Robotics as a word is a scary word. Some people will say, "Wait, that's too much for me." But you can really, a robot doesn't have to be a 5 degrees of freedom. You can use 1 degree at a time. There's technology exists using a system that sucks or grab a member and put it where you need. Conveyors could become part of the robotic system. So you don't need really to have it all in one, but down the road you can see the demand for robotics when you really get to that point that you're capable of or having readily available resources in the market to help you move to the next level on the robotic applications. I showed you earlier the wood framing. That wood framing is made of components, pieces. Those could be prefabricated using robotics, windows, doors, drywall, other members could be installed the way the human will do it. The motion, you can copy that motion into a robotic arm. You can make it a system, so all of a sudden you get some human interacting with robotics. Again, it required way more planning because the robot need to know where all these pieces located, so with the high precisions. Unless you add machine learning and cameras that the robot will understand and find its way around. But and the last part of this is really linear production. So if you look at this as a window manufacturers, when you come to install the hardwares, all these hardwares will be installed in a 2D window. After welding, the window will become a square or rectangular. And then the human will start adding the hardware with proposing to have the hardware before you weld. So this way you can isolate the workers and perhaps will reduce the risk of transmission of the viruses between workers. And also we discovered that it adds to the efficiency of the factory. So if you look at the work that what we propose, we did that in the lab. Now I think in the next couple of weeks we'll deploy this technology in this in this factory that will work in linear production, and we discover a little bit of efficiency increase in the process, reduce the space, and so on. And the last item I want to talk about here, which will be the virtual reality and machine learning. So I may ask all of you around here, you've done some renovation at home, and how difficult it is to make choices. For light fixtures, for the cabinet, for the so there's so many choices, and some of it really limited, and some of it almost unlimited amount of choices. So I just took a picture of a stove or oven. There is so many. Which one that's the best to choose for me or for my household? Looking at the faucets, variety. Is it the cost? Is the criteria? The look, the shape, and go on and on and on. So light fixtures, there is a very a large amount of variations and quantities and look and shape and so on. So it's very difficult for human to make these choices. So what we're trying to see in this particular research is if I can get the database and use machine learning, and I'll go up here before I come to this slide. If I can put all this information, profile the people based on where they come from, their age, level of income, and so on, and somebody will come and use the same with the virtual world and make the choices for his or her kitchen, for example, or bathroom. And then if I can profile based on that, I can say, well, listen, people with your where you come from, the level of income, whatever you are. This is the way they choose. This is what they like in terms of kitchen, in terms of fixtures, and so on. So that's what we're trying to say. People could be Asian, African, Middle East, and just for the Brazilian, I know there's lots of people from Brazil watching this particular presentation. You can put a smile in a Brazilian man if you put a barbecue, because Brazilians love barbecue. So maybe something that to make a choice for that. So in a bottom line, as a professor, as a scientist, or as an inventor, we need to really to satisfy the criteria that not only us or the government look at. So first, we need to be mindful for the environment, make sure that we reduce the waste when we do what we do. we do things based on efficiency, high efficiency, because you cannot really rely on the resources we use. And so we also have to be mindful to the bottom line, whether industry need to make profit, and also those who buy the home should be able to afford it. Job opportunities, we need to be part of creation of job opportunities, not only a single job, it could be a good quality job. Yes, you can frame, you can work on site, but if I bring you to factory, I'll give you the opportunity to be trained, training, and then we'll focus on the functionality of the family, so people can work in the factory in an environment that allows them to be healthy, and when they go home, they are not really tired. They can have time to work with, to play with the kids and enjoy some meal together with the family, rather than being very tired, working very hard, long hours in the day. Before I conclude this presentation, I'm taking these pictures from Lafayette in the past. They had the factory, which you go there and you focus on the product, what you do and how you do things. But they transformed the factory into something that's becoming really a museum, if I want to call it. And I really will urge you to contact Lafayette and go and visit the factory. This is what used to be, and this is what it is today. And what you see in my background, they allow me to use this picture, which is today Lafayette. It looks like what you see in my screen here. So they care about the people, because you're spending more time in this factory than you're spending at home. You want to enjoy the time in the factory rather than focusing on what you do. So the atmosphere is changed. Professor Jones, this concludes my presentation. I'm open for any questions if there is any from the audience.
Thank you very much. Excellent presentation. And I want to say that I share your view on a construction that is better for people that is working, that people are better treated, and I certainly share the view that it's important to generate jobs, but the quality of the jobs are very, very important. And without increasing productivity, without improving, putting machines, we are not going to change the sad reality that it's construction. And thank you very much for your presentation.